Hello everyone. I hope the voice is clear. So just to check, Engineer Ahmed, can you hear me well so far?
Yes, I am hearing you well. Thanks, Engineer Adil. Well,
Okay, I appreciate it. So I think it's time to start our 86 free webinar, and you are all welcome to join this interesting one regarding Saka rope bumping system. We will just take like normal, just 5 or 4 minutes to have like a brief intro about our upcoming courses plan. So before that, Engineer Ahmed has been graduated from Cairo University, and he has around 12 years experience in different disciplines like work over completion, artificial lift water flooding, production technology, and regular operation. And I think in this webinar, he will cover different concepts about Sakar rope bumping system, which is will be like, it's like a short intro of our upcoming course with Engineer Ahmed as well. So this is like a brief intro about our upcoming courses plan. As you know, this is our 11th wave of courses, and in this wave we have 6 courses. We already started with the analytics and the machine learning applications oil industry. The upcoming one will be the Sakar root system, and Engineer Ahmed will be the instructor for this course. We also have IMBAL best practice, process safety management, and we have 2 reservoir simulation courses, one regarding practical reservoir simulation using Betril, and the second one will be polymer injection using the CMG. So you are feel free to view or enroll directly through our website www.opecourses.com, or you can scan this code, or you can contact us directly, whatever your want. So also we have like a mega offer that if you interested in 3 courses, we will give you the other 3 remaining as a gift from OBA. And now we have like we still have remaining 3 days until closing of the Eid al-Adha offer. It's around 50% discount and 60% for our ambassadors. You can see now around more than 40 ready courses recording on our website. You can go directly, or you can contact us for if you are interested in any one of these courses. And here's like a hint about mentorship. If you are a master candidate, PhD candidate, or also a professional who is seeking some advice from experienced engineer, you can contact us. We delivered around more than 45 mentorships, delivered by more than 12 mentors to different countries, mainly for master and PhD candidates. And here's like a look about our website. If it is your first time to go and visit opecourses.com, I invite you all to go and check. I think you will see a plenty of courses that will boost your performance. And finally, OPE Ambassador means that you already enrolled in any of our programs like live course, mentorship, internship, and so on. And after being an ambassador, so that you have like discounts and coupons. So thank you. This is our social media, and Engineer Ahmed, mic is yours. Feel free to start your webinar. Thank you.
thanks, Engineer Adil. Bismillah ar-Rahman ar-Rahim. Hello, everyone. I hope everyone in good health. Today, I will give you overview about Sakar road bumping system. This course, which will be presented through OBA. So, we will answer a few questions which will give us a complete image about the course and the details which will be discussed during the course, inshallah. These slides will answer the following question. The first question is why we use artificial lift. The second one, how can we assembly and disassembly beam pumping unit? How can maintain and follow up beam pumping unit operation? What is the usage of sucker rod string? What is the difference between normal and guided and any other type of rods? What is the importance of DIFA, which will be done on downhole pump in the workshop? How can design sucker rod system? How can optimize our production by sucker rod system? The first question, why we use artificial lift? as we know, to know first the types of oil wells. The first type of oil wells is the self-flow wells. This well has the capability of flowing naturally from reservoir till surface facilities because these wells have a high reservoir pressure. The second type is non-self-flow wells. The non-self-flow wells which cannot flow naturally because the low reservoir pressure or depleted well. As we know, the intersection between vertical lift performance and the IPR, this is the meaning the naturally flowing well. This well can flow naturally by this flow rate at this bottom hole flowing pressure. This will flow naturally to surface as the reservoir pressure is very high. Is very high enough to overcome hydrostatic head and the tubing friction or any back pressure, in addition to provide us with well head pressure. This well head pressure have to be sufficient to transmit the flow to production facilities. This mainly happen initially at the start of well life, but after time, the well which producing naturally will be in the intersection will be missed and become dead well. This dead well has low reservoir energy that is not able to deliver fluid to surface. With time, naturally flowing wells suffer from depletion, which is result from decline in reservoir pressure and become dead well with time. How can retrieve this dead well to flowing well again? The first thing to enhance or support the reservoir pressure and enhance IPR. How we can support the reservoir pressure? By injection, any type of injection, water injection, polymer injection, gas injection. All these type of injection, the measure or the objective of the injection to support the reservoir pressure. We can make a reservoir stimulation to enhance the IPR and become the vertical lift performance with IPR intersected again. How can we make the reservoir stimulation? By reperforation, acidization, fracking, any type of chemical injection. This enhances the IPR and intersect again with vertical lift performance. So this well can flow naturally again by this flowing rate at this bottom hole pressure. But if we enhance it, the IPR and still the intersection between IPR and the vertical lift performance not intersected, what I will do? So I force it to use the artificial lift, any type of artificial lift, like gas lift, ESP, sucker rod, jet pump, any type will come the intersection again between vertical lift performance and the IPR. This intersection means the well will produce again. Okay, what is the objective of the artificial lift? The objective of artificial lift, or the main objective or the use, apply the drawdown to give the fluid energy to overcome hydrostatic head and overcome the tubing friction and give us the flowing pressure at the surface. This pressure will transmit the fluid to the process facilities. Here, the reservoir pressure is very low, give us a static fluid level, and the fluid stop at this point. So I need the energy to overcome this pressure and give us flowing pressure at the surface. The artificial lift make drawdown and support the fluid by energy, which will overcome the hydrostatic head and tubing friction and give us flowing pressure. Now we answered the first question, why we use the artificial lift. The second thing, how can assembly and disassembly beam pumping unit? This will be discussed in details during the course, but I will give you overview about how we can assembly and disassembly beam pumping unit. At first, we have to know the parts of the beam pumping unit. What is the main part of the beam pumping unit? The main part is the concrete base, then the steel base of the beam pumping unit, which will assemble all parts above this unit base. This is the prime mover. Prime mover is the source of the rotational movement, which will be transmitted to the gearbox by V-belts. These V-belts and the prime mover will generate the rotation movement. Then this movement will transmit to the crank arm and the Bateman arm. The crank arm and the Bateman arm attached together with crank pin. These two arms is responsible to transfer the rotational movement to be up and down strokes. Attached here with equalizer This equalizer attached with walking beam by equalizer bearing. Here is the center bearing, which attaches with walking beam to transfer this up and down stroke to the downhole equipment. This is called the Samson post with 3 legs. This walking beam, horse head, and the wireline beam to attach it with carrier bar, which will load the sucker rod string on the carrier bar. So the main part is of the beam pumping unit, which will be assembled. How can we assemble beam pumping unit? Or what is the meaning or the main objective of beam pumping unit? Beam pumping unit responsible to transfer the rotational movement and transfer it to up and down stroke to produce the pump. The pump need up and down movement to produce. So this is the source of the up and down stroke. Beam pumping assembly will be done as the following steps: foundation and ground leveling, base installation, then crank pin installation, reducer installation, master counter weight installation, Samson post installation, ladder installation, prime mover installation, walking beam center bearing and equalizer, Bitman installation, walking beam, the whole walking beam equipped with the horse head and center bearing and equalizer bearing, horse head installation, and the end crank guard for installation for safety. Okay, this is complete assembly for beam pumping unit, which will be discussed in details during the course, how we can assemble from A to Z for this beam pumping unit. The third question, how can maintain and follow up beam pumping unit during operation? The maintenance and the follow-up for beam pumping unit classified into 3 major steps. The first one is daily and monthly, every 6 months. Daily or monthly or every 6 months depend on the most important 3 words: look, listen, and apply. We will begin with daily. Daily look for the unit on daily basis to observe any change in the unit alignment or any wire line tracking and anything else changing during the last 24 hours. Listen, we have to really listen it for any noise as a gearbox or structure bearing, rumbling, bobbing, clicking. Any noise will come from the beam pumping unit is indication for any for beam pumping unit failure. Apply the brake slowly but firmly to assure it is in good working condition. For safety, because if we wanted to make any maintenance for beam pumping unit, we will use the brake. Monthly, we will repeat the most important word is look, listen, and apply, which is done in daily, and check for oil level in gearbox to ensure it is in the proper operational level. Review all bolt condition visually. For every 6 months, we will repeat the 3 words, look, listen, and apply. But we will here check significant bolting for proper bolt tightness, take a sample from reducer oil, and take a sample from the relieved grease to know the condition of the bearing and the condition of the internal parts of the gearbox. Why we use the sucker rod string? As I said before, this pump need up and down stroke to produce. So the up and down stroke generated from beam pumping unit at surface. The sucker rods is responsible to transmit this up and down stroke from beam pumping unit at surface to downhole pump at the downhole. So this is the figure or the shape of the sucker rod. This part is responsible to transmit the energy from beam pumping unit to downhole pumps. Is the mean the chain between the beam pumping unit at surface and the downhole pump at the downhole. Sucker rod string consists from bullish rod. We will speak from surface to downhole. Bullish rod, bony rod, multiple interconnected rods, coupling, sinker bar, stabilizer bar, at the end, the pump, the downhole pump. The sucker rod failure. During the course, we will speak also about the sucker rod failure, which is done during the operation. This failure because of, sorry, because bad design of sucker rod to check the rod loads. The most common failure is the rod parting. Rod parted, we have at first to determine the top of fish because we have to determine the parted rod size to determine the top of fish. Why? If this rod parted from body, from coupling, from thread or shoulder to determine determine the suitable overshot. Sucker rod care and handling will be discussed in details during the course because it is the mean or the effect on the lifetime of the sucker rod and will be the main cause of the rod failure. And we will speak about sucker rod handling tools. These handling tools is API and standard handling tools which will be used during running hole or pull out of hole with sucker rod. Have to be as per standard to prevent any failure for the sucker rods. Downhole pump. The main parts of the downhole pump is the barrel. This barrel attached at the end with the standing valve, the traveling valve which attached with the plunger, which is responsible to transfer the oil from the barrel to the tubing. A standing valve at the traveling valve, this is called traveling valve, and this called standing valve. This valve rod hold down or sitting assembly is responsible to hold the pump inside the tubing. This video will show us how the downhole pump or the sucker rod downhole pump working generally. At first, in the upstroke, in the downstroke. In the downstroke, as shown here, the traveling valve in open position and the standing valve in closed position to transfer the fluid from the barrel to the plunger. But here in the upstroke, the opposite thing will be done. The standing valve in open position and the traveling valve in the closed position. This open position to transfer the oil or the fluid from the downhole inside the barrel. And this action will be repeated to produce by downhole pump. I think it's clear now how the downhole pump is working. This video will show us the internal parts of the downhole pump. This is called the traveling valve, and this pole and the seat of the traveling valve. This is called the cage of the traveling valve, and this cage bushing. The traveling valve attached normally to the plunger, which attached with the valve rod to move up and down. This is called the plunger. This part is the valve rod, which will transfer the up and down stroke from the sucker rods to the plunger inside the barrel. Then the barrel attached at the end with the standing valve. This also consists of ball and seat, and the cage bushing will attach with the barrel at the end. This is hold down, which is responsible to seat the pump inside the tubing in the pump setting nipple. This type is called the cup type. This part will attach with the pump in the barrel at the top, as this called the valve rod bushing. This reciprocating movement which will be transferred by sucker rods. Now we will show how this pump working. This downstroke and upstroke movement, this called the sitting and traveling valve. What is the meaning of pump name? If we have pump name called 30-175 RHAM 26 4 and 2, what is the meaning by this name? Every pump have a name. The first two numbers here If it's 30 or 25, refer to the tubing size which can this pump run in. How? If this called 30, this pump can run inside the tubing size 3.5. If this number is 25, this pump can run in whole inside the 278 tubing. The second number is 150, 150, or 175, or 225, and so on. This is called for pump bore size, the pump size itself, and this will affect on the well production and the pump production. If it 150, it called 1.5 inch pump. If it 175, it is mean 134 inch pump. The first letter here may be T or R. T for tubing pump, R for rod pump. What is the difference between two types? The rod pump installed inside the tubing, but the tubing pump is a part of the tube. So it will give us a huge production compared with this type. But in case we wanted to pull out of hole, here we can pull out of hole only with the downhole pump. But in this case, we will pull out of hole with all completion string to replace. The second letter is W or H. W for thin wall barrel. H for heavy wall barrel. It will be discussed in details when we will use the thin wall barrel and the heavy wall barrel. The third letter here is top A or B. A for top hold down, B for bottom hold down. What is the meaning of top hold down and bottom hold down? If the pump is sitting from the top of the pump, it is called the top hold down. If the seating is at the bottom of the pump, this is called bottom hold down. This letter may be M or C or A. M for mechanical type, C for cup type, A for anchor type. This meaning is a type of hold down. If this hold down like this, it will call the mechanical. If it's like this, it will be a cup. This type is anchor pump. This number for barrel length. What is the barrel length? Which pump? Every pump have a barrel length. This barrel length in feet. This number called for plunger length. The plunger which will move inside the barrel. What is the length of the plunger? This being the plunger length in feet. The last two numbers for extension length, and we will discuss it in details. What is the meaning of extension length and how affect on the pump production. For example, this pump 30 175 RHAM 2642. This pump is can run in hole inside 3.5 inch tubing. 175, the pump size is 1.34 inch pump. R for rod pump, heavy wall barrel, top pump, mechanical hold down. The barrel length is 20 feet. Plunger length is 6 feet. Extension have two extension. One of them is 4 feet and the another one is 2 feet. Downhole assembly and disassembly. The main objective of downhole assembly or disassembly is for downhole pump maintenance or for DIFA. DIFA is dismantling for inspection and failure analysis to detect the main cause of the failure and replace the parts which damaged and need to replace to run in hole again with downhole pump. The disassembly steps: preparing for the required handling tools. Every workshop, every sucker rod workshop have handling tools for DIFA. Visual inspection, if we have scale or sand production in the outside of the pump. Clean all components before inspection. Dismantling for valve rod and the guide rod. Then the hold down and standing valve cage. Barrel inspection, plunger inspection, and the ball and seat inspection. Barrel inspection and the plunger inspection and the ball and seat inspection need special devices for inspection and complete the DIFA. How can design sucker rod? This is the most important question because we need software like S-Rod, which provided by service company. This sucker rod designed to select the suitable pump and the desired production rate. Select suitable rods and the rods loads. Select the required beam pumping unit as maximum torque and maximum load, which will be used for this well. Determine the stroke length as the stroke per minute for the operation to produce the desired rate. This software will be discussed in details during the course how to design the sucker rod from A to Z. From beam pumping at first for pumping unit, for the sucker rods, for the downhole pump, by selecting the desired rate and stroke per minute and stroke length. Also, downhole card interpretation. What is the downhole card wanted to tell us? This card also give us the first indication for downhole problem and condition. This will be different for interpretation. We need to tell us we have a problem in downhole. What is the problem? What does that mean, this card, and the difference between every card? We will speak also about sensors and SAM controller and the installation of the SAM controller and the sensor on the beam pumping unit, which will give us the downhole cards and will be interpreted the downhole problem. At the end, how can optimize our production? The beam pumping unit depends mainly on this equation, pump displacement, which is called BD. This gives us the barrel per day. D for plunger size or the pump size. N for pumping speed by stroke per minute. SB plunger or stroke length in inch. So this equation will give us the first indication how can optimize our production by using a sucker rod, by change or replace the existing pump by another size, or increase or decrease the stroke per minute, increase or decrease the plunger size or the stroke length. All these actions will be discussed in details, especially how to change the stroke per minute and the stroke length. So I wanted to ask you some questions and to think about it. The first one, what is the lever type of the conventional beam pumping unit? Second, what is the use of the anchor pump? What is the common workshop devices used in DIFA? What is the main use of the sinker bar and the stabilizer bar in the sucker rod string? Thank you for listening to me. I hope that the webinar was useful for you. Thanks for your valuable time. If you have any question, please don't hesitate to ask me. Thanks.
Thank you, Engineer Ahmed, for your webinar, and thank you all for your attendance. So if you have any question, please use the chat. So does anyone have any question? So, Engineer Ahmed, I think there is someone asking about what is the case if the well needs a periodic treatment.
Need for what?
And also, someone is asking about the software used for sucker rod. And second question is, he's asking about if there is if the well needs a periodic treatment.
Chemical treatment?
No, not chemical. He's asking about periodic treatment.
Yes, periodic treatment. The first questions, we have two types of design. If we have S-rod or sucker rod, S-rod, these two softwares which specialized for the sucker rod design. This will give us all data for the beam pumping unit. If we need to select the required beam pumping unit, what is the maximum torque, what is the maximum load in the sucker rod, determine the stroke length and stroke per minute. Then the design for the sucker rod string itself, what is the load on every rod, what if we need guided rod or normal rod, we need the stabilizer bar, how many stabilizer bar we need. Then design the downhole pump itself. What is the pump size required for the desired rate? Select the production rate. This is the most important thing we have to select. Okay, about the periodical the maintenance for beam pumping unit or downhole. For downhole, we always run the downhole until we want to check by inspection or by maintenance and follow up for downhole. But for beam pumping unit, it is the most important because the most cost of the sucker rod pumping, the sucker rod string is the beam pumping unit. It is the capex cost and the huge cost. So we have to make the periodic maintenance for the beam pumping unit, especially for bearing, the light greasing. The gearbox is 80% of the 80% of the beam pumping unit cost. We have to check the oil level. We have to check if we have any foreign material inside the gearbox because it indicates the gearbox have internal damage, have to be fixed. So it will be separated for daily and monthly and every 6 months to detect the problem before any huge failure. Okay, Engineer Adil?
Yes,
Engineer
yes.
Adil?
Okay.
Uh-huh.
I think someone's asking about MACD type of unit and the application of each unit.
Asking about what?
Mr. Magdi is asking about the type of unit and the application of each unit.
The pumping unit types.
Maybe yes.
We have a different type, like conventional and Mark II and air balanced. Every type of beam pumping unit have a different specs and have a different setback from the well and have a different assembly and disassembly. But is the most common beam pumping unit is the conventional and the beam pumping unit which called Mark II. We have another types but not used and commonly used. So the manufacturing and the supplier will now supply only the conventional unit because it is applicable for different oil wells.
Okay. We still have some questions. Engineer Ahmed seems like it was an interesting discussion. So another question is about what type barrel components do you recommend for excessive sand production?
Okay. The disadvantage of the sucker rod is the sand production and the scale production. Because the beam pump, the downhole, the sucker rod pump cannot handle any sand production or any scale because it may cause a big failure and pump stuck. So we not recommend the downhole sucker rod downhole pump for sand or scale production.
Oh, okay. So I think the last question is by Muhammad Khan. Is there any chance of an air block?
I'm sorry,
He's asking, is there any chance of an air block?
air block.
Yeah,
I'm sorry, what is the meaning of air block? Air in
uh,
maybe gas lock.
maybe yeah,
Maybe he mean gas
yeah,
lock.
maybe yeah.
Yes, the gas lock it happen when the downhole is producing a high gas oil ratio. This will make gas lock inside the downhole pump because the standing and the traveling valve may be lock at the open position because of existing this gas. This means the pumping will be moved up and down inside gas and will not produce any fluid because the standing and the traveling valve in open position and the oil will be slip down and they cannot handle any fluid because the gas is fill the barrel and the plunger of the downhole pump.
Okay. Two questions has raised up again. So, what is the suitable depth for BPU and how can you determine it?
Okay. We can determine it by the maximum torque rating on the beam pumping unit. We can use beam pumping unit for shallow depths because it handled low load. And another one like 1280, it is for high deep wells. But the maximum depth which can handle by sucker rod around 10,000 feet. And it will be based also for the sucker rod string and the type of the fluid.
Okay. I think this time this is the last question, which is what is the difference between surface card and downhole card?
The surface card for which will give us indication for the beam pumping unit itself, but the downhole card will give us the indication for the how the downhole pump work. If we have gas lock, if we have oil slippage, we have a tubing movement, we have a gas fluid bound. This give us indication for beam pumping unit, and is another for downhole pump.
Okay, so seems like the discussion was interesting. So any more questions? I think more than 10 questions is very good indication. So if anyone has any questions, so feel free, please. Many thanks for this good presentation. Thank you. Oh, we have a question from Engineer Ahmed. What type of oil does it use? BBU.
What type of oil? Sorry, Engineer Adil. Engineer Adil.
He's asking what type of oil does it use? BBU.
BPU, beam pumping unit.
Yeah.
The oil, the beam pumping unit can handle all type of the fluids except gas. Except gas. We can handle it the water. We can handle any type of oil, heavy, light. We also have a limitation, but no limitation except the gas production and the sand production, scale production.
Okay, I think this is the last one. So special thanks to Jean Ahmed for this interesting webinar.
Thanks to you.
Yeah. So another question is the why accept gas? Space is asking why accept gas. Actually, I don't want to finalize the webinar with and let some questions that may add some information. So Faiz is asking why accept gas.
The accept gas for gas oil ratio. Do you mean that, صح?
Faiz, if you can clarify it a bit more. Yes, he is. Yes, yes, yes. He said yes. Okay. Engineer Ahmed, he said yes. It seems he means the GOR. Yeah.
It means GOR.
Yeah.
Sorry, I have some problem with the internet. I'm sorry.
Yes,
What is it? What?
he's referring to the GOR. Yeah.
Yes, it is different from. He mean the gas oil ratio which will be accepted for the sucker rod. Okay, that's he mean.
So I think he's asking about the acceptable range of this.
Yes, wait a second, because I'm looking for something for characteristics which will be used for different type of artificial lift. It will be useful for gas oil ratio because this question may be repeat again and again. Gas oil ratio can handle it for sucker rod pump for 500 gas oil ratio. It is compared to another types of artificial lift. It is not high. It is very low compared to the other, like gas lift, for example, like ESP, because have a high limitation because it can handle it high gas oil ratio because it can handle with gas handler or gas separator. But for sucker rod, 500 is enough.
Okay, so Jim Muhammad is asking if there is like a gas block. Can we solve it, or how can it be solved?
We can solve it, but I not recommend for high gas oil ratio we use sucker rod. But if we have, for example, gas lock and we have low stroke per minute, high stroke per minute and low stroke length, we can handle it by increase the stroke length to maximum and decrease the stroke per minute for minimum value. This can overcome the gas production for the time, not forever.
Okay, great, Engineer Ahmed. Again, thanks a million for your presentation, this nice, interesting webinar, and hopefully we can deliver some of this in the future, inshallah. Thank you. And thank you all for your attendance. Thank you. Thanks a lot.